All right, lesson 17, page 74 of Algebra 1. That's where we're going to start off today. We're going to talk about things called factors and coefficients and terms. So we're going to just define some things. The book talks about coefficients first. So they're giving us this term here for xy, and we know that when they're together like this, that they basically mean 4 times x times y. Okay, and they're saying that all of these are coefficients. The 4 is a coefficient of xy, x is the coefficient of 4 times y, y is the coefficient of 4 times x, etc., etc. So it's a lot of things can be considered a coefficient. A coefficient is just part of the multiplication problem, okay? So then there's something called a numerical coefficient, which is easy peasy. That's the number 4, number negative 15 here, number 81 in this one, okay? And then it says a literal coefficient. It says if the coefficient consists entirely of variables or letters, as in B, C, and D above, we call it a literal coefficient. So a literal coefficient doesn't have the numbers, okay? Maybe it would just say xmz or pq or xy. So there'd be no 4, no negative 15, and no 81. That would be the literal coefficient. The numerical coefficient is the number in front, okay? So then we have words called terms here in the middle of the page on 75, and they're giving you examples, okay? So it could be a single variable or constant, so it could be a number, a letter, those multiplied by each other, and then a more complicated term where you're adding, multiplying, and dividing. All of this together is supposed to get you one answer, so that's one term, okay? So then we have first term, second term, third term, fourth term. So you go from left to right. If you wanted to say, what's the third term in this equation, you would point to this one. This is the first, second, third. So it'd be 6p divided by y plus 2, okay? So this is just helpful to know when your book says, you know, what's the third term, or simplify this term, or multiply this term by something else. You know what they're talking about, okay? It's just basically anything in one of your math problems. Okay, so let's talk about something called the distributive property. They start talking about this on page 76 of your book. And so to kind of summarize it, it's just following a different way of multiplying and adding terms together, and you're going to get the same answer. So let's go to this right here, 4 times parentheses 5 minus 3. We want to do the parentheses first, just like in our normal equation, where we work from the inside out. So 5 minus 3 is 2. 2 times 4 is 8, okay? Excuse me. So that's really easy, okay? So there's another way you can do it where basically you're multiplying first and then subtracting. So here we subtracted, or we added a negative 3 to the 5 to get the answer, and that's what we did first. But now we're going to multiply first over here on this side. So what we're going to do is we're going to take our 4 and we're going to times it by this number. Then we're going to take it times that number. So 4 times 5 is 20. 4 times 3 is 12. We need to keep that minus sign in there because it's basically like saying this is a negative 3 times a positive 4. So that's negative 12. 20 minus 12 is 8. So if you see, both ways we use to solve this equation is going to get us the same answer. So this is called distribution. When you distribute the term that's on the outside and you multiply it through each term on the inside. So remember, this is one term, this is the second term. So you take this one times the first term, this one times the second term. If there was a third term, you would do the third one, etc., etc. So I will give you another example. Okay, so this example is going to have a variable in it. It's going to have that x in there. Okay, so remember, we're going to take this term, the -3 term, and we're going to times it by the first term, and then we're going to times it by the second term and find our answer. -3 times 2x is going to be the first thing that we do, and then I'm going to put a subtraction sign and take a -3 times 4 would be -12. Okay, so you can do this two different ways. So here I pretended this was like a positive 4 here. Okay, so I took -3 times let me write it so that it's not sideways there, times a positive 4. -3 times a positive 4 is a -12. And then I keep that subtraction sign and I bring it down here. The other way you could have looked at it is you could have said, well, basically this is -4 and this is -3. And if I times these by each other, I'm going to get a positive 12. Okay, so you could have had a plus 12 here, which is what we're going to end up with anyway, because two negatives beside each other become positive. So it becomes plus 12 either way. So you just need to figure out what is the least confusing way for you to do it, and then just be consistent with that. Okay, so here we are going to multiply this through. -3 times 2x is -6x plus 12. That is our answer. We can't make it any more simplified than that because we don't know what x is. Okay, so this is not the same kind of term as 12, so we can't add the numbers together yet. So this is the answer to that question. Okay, so here's another example, page 77, letter E. We're going to distribute this through. All right, so we're going to take 2m times xy. So just so you know, you are pretending that these are all numbers. So this could be a 1, this could be a 3, this could be a 4, and you're multiplying them together, okay? So you don't know what they are, but you just pretend that they're numbers and figure out, well, what would this mean if I had real numbers in there? Okay, so if I had real numbers in there, okay, well, I have 2 times a real number, and then I'm taking it times another real number, x, times another real number, y, and I'm going to get an answer. So 2m times xy would be like saying 2 times m times x times y. So if this was a 1 and a 3 and a 4, you would just multiply them all together. So that is how 2 times m times x times y becomes this. Okay? Same concept here. Excuse me again. You have 2 times m times -3 times p. I'm just going to keep this negative because I know that a negative times a positive is negative, okay? So a 2 times a 3, those are the same kind of number. We know what 2 times 3 is. We know that that's 6. We don't know what number m is yet, so we're just going to say, well, once we know what m is, we're going to take m times 6. And once we know what p is here, we're going to take m times p. So we're going to take -6 times m times p to figure out what the answer is to this. Okay, so this is our answer. It doesn't look simplified. It's not just one number. It looks odd and clunky, but that's what Algebra 1 and Algebra 2 are. It's big, clunky answers that actually mean something once you know the value of these variables, okay? So that is your answer to this question when it asks you to distribute. Okay, one last example, letter F, page 77. We're going to distribute the xy through our parentheses. So that's xy times a. So this is like saying x times y times a. Then we're going to do here x times y times b. I'm going to keep my minus sign because a negative times a positive is negative. So we've got a 2. And then we've got x, y, and c. Okay, so this is my answer. These variables can go in any order you want them to, but it's good to be consistent in how you write them. Like I will always write the numerical coefficient first, and then usually I will write like my highest exponent value. So maybe if this was x squared, then I would put that there. Or if this was y squared, then maybe I would move it over here. But we can talk more about that as we go. But I just want you to know that it doesn't matter if this says negative xyc2, it's going to be the same thing, because it doesn't matter if you take 5 times 3 or 3 times 5, you're going to get 15 no matter what order it's in. So just remember that. So if you have an answer in your book that says something like AYX plus BXY minus X2CY, this is actually the same answer. It's just written in a different order, okay? This is still taking X times Y times A. This is still taking X times Y times B. And this is still taking 2 times X times C times Y, just like we did up here.